Hello. So I want to discuss the different types of physics that I learned and how they relate to each other. And basic. Oh, this is not. So basically, it's the level of precision in each one. So the first one is GE. Then there's engineer slash other, which is basically engineered physics and other majors that need physics. And there's physics for physics major. The degree that the difference of these three is precision. The precision in here is pretty much non-existent and also quite basic. The precision in here is better, bigger, and the precision in the physics major they care a lot. For example, sig figs. That's basically the main difference between these three. And the GE course over here really does not cover. I'm just describing what I felt like when taking the 2A and 4A series. Does not cover any of the two anything mostly related to 2A. It's just does a very basic 1D motion, while 2A does a 2D motion, which is kind of funny actually. Think about it, the name actually makes sense. And 4D goes cares about everything really. So I described that. So 2A cares about the component vectors, but other than that, they don't really focus too much on anything else. Oh, actually, that's going to be erased over here. So yeah, and then 4A does care about these kind of questions where we have two systems and we're asked to get the t seconds um, where they meet each other, and there should be two solutions here. No, wait a second. Two times, so it's like this and this. So, yeah, that's how they meet, and the particles meet each other at 2 points. Should be because oh yeah, if you what you have to do is say 5x. Oh, this is a horrible pen. Here, 5x squared. I don't even know the answer to this. I haven't done this problem because I just made up the polynomials. So I don't know. So you can see that that is kind of the objective here. And wow, that's a horrible polynomial. Um, well, they will not give any complex numbers. If it's complex numbers, there's no solution. So I hope I accidentally created something with a solution. If not, then I have to redo this question. 4, 12, 12, 4, 4, 8. Yes, this has a solution. So as you can see that there is two answers here because the plus minus, which means there is two positions uh, if you name it, that has the time meeting each other, because this will give you t. The velocity over here, which is quite funny because you just have to take the derivative of this one and plug in both times. So there should be four velocities and four accelerations, but I don't think you need to write any acceleration. You need the meeting point you just plug back into here. And again, there should be two of them. Good to know. All right, the next question I'm going to talk about is another precision-based question. But before we do that, actually, there's another question that I just saw that might be useful for to talk about, actually, because well, it's basically some objects flying back and forth while wind is blowing in. There's part A, part B, part C. The part A, part B is I'm not gonna give the question out because that's not allowed, by giving a similar question um, because that's like in the public domain afterwards because I made the question at that point. Part A and part B is not needed for this thing, but part A and part B is just a math, but part C is where it gets fun because that's where the description comes in. And that's another thing that 4A cares about. So in 2A, part A and part B, and one A, part A, one B, well, actually probably one A only, is possible. Basically, getting the speed or the velocity of the bird, or how long it takes for it to come back and forth. That is a good question for that. But to the C part C of the question, where they ask what's discuss how the wind or something affected the travel. That is 4A stuff. The engineers don't need that, and probably other majors. So now this one, why I'm talking about that, this is a level of precision in 4A versus 2A, because 1A, or known as GE, doesn't care. Honestly, they don't care about the direction or anything. They just want the motion. So, if this is somewhat happening, let's just say I don't like those. Well, no, 3 0. So v squared divided by r, we know that equals acceleration. A equal 9 divided by 5 is acceleration meters per second. So that in 10 seconds, or 20 seconds, or whatever, 1 second. Let's just say 1 second. It's easier for me. That is good enough. That is good enough work to be done for a two-way series, because there's no precision, there's just acceleration at some point, and the acceleration is, you just have to say moving toward the center, um, which is good enough answer. Velocity is 3.0. This way is also good enough, but in reality, well, if you're doing 4A stuff, precision matters. So in 1 second, you have to determine where it is by using I and J. And that's the main point here. The precision I and J is what's important. And then you have to use some really funky stuff where you have to WR, then the cosine I and J here. J, I and J. Um, Cosine is x, sine is y. Yes, that's right. So that's what you have to do, which is why it gets confusing for it. I'm not solving that. Anyway, next problem in 4A that doesn't show in 2A unless you take a major course in engineering, which needs it. But in 2A series, there's others, right? So they don't need this shit. Um, and the funny part is, I think even to a some parts of this is not necessary, but yeah. So the tension of these ropes are all T1 and T2, T3. Actually, I think I drew this wrong. Oh, I did do this wrong. Oh man, sorry. Not really sorry, but yeah. I'm just gonna make this bigger. Um, Donut, and then I'm just gonna move that up. That should be good. Just imagine those two are the same, and just something like this happen. And this is up, and somehow this is straight line to over here. Let's cancel that out. Did I do this wrong? Well, doesn't matter. The tension on these three are the same, but what I found out in while studying for exam is that they don't really talk about the acceleration that much. Um, yeah, sure, the tension is fine. The tension is all equal to each other because this is one line, the rule of one line. Um, if you add another thing like this, and then to another mass, then the tension over here and here is the same, but it doesn't equal any of the other three. That would be considered a different line of approach. Uh, okay, and we're assuming massless pulleys and massless tension strings, whatever, I don't know. So T1 equals T2 equals T3. But the acceleration is different because if this is accelerating downwards, and let's just say this is accelerating upwards, then the tension length over here um, is double here, 2A, and then this is A and A. So those are the A's over here. So 2A M negative, and that's positive because it's going up. and then over here would be no, sorry. This would be uh, MA over here, 1. Just say that's 1, and that's 1, 1. Over here would be 2am1 will be negative here, and then you just count, and that equals to all the tension force and other things you learn later. You learn at that point, but the precision here is what I'm trying to get at. They don't in the 2A series. They only care about this kind of system as a pulley system until later on. That's the main point about these three differences and what we learned. Uh, and what I figured out is I taking the it's already halfway done with this course, so that's the difference I found out. There's 10 minutes left, so I'm done talking about that. I'm such a boring person to want to talk about this shit. Uh, yeah, I did want to talk about that for one reason or another. Because anyway, I'm gonna have to end this here because I accidentally showed some